Well, Jason, we spent 2 days downstairs. You got to throw a lot of different bowling balls, and at the process of elimination, we got it down to one. And in all that time and effort, we came up with a shape right here.
So that's the shape
That's
there.
it.
Okay. So first, it looks really cool. I guess my question to you is, how do you even design that? How does it go from a blank screen or a blank piece of paper to that?
Well, the biggest thing is, I mean, you're trying to create ideas from what you've given me in the past, and we talked a month or so ago about balls that you really liked. The ones you had success with was Critical Theory was one of those ones that stood out. Now that was an idea or a design there where we took some ellipses and we created a big body mass. If you see the one on the right.
So that's the Critical Theory block.
Yeah, so that tri-elliptic core, so we had a big elliptical mass in the middle and then two small ellipses at the top, which created if you put it in motion, it creates what we call a kind of a helical effect.
Yeah.
You had some good successes with this ball.
Yeah.
Lower RG ball too. So it was one of those things, as you know, in our conversations about balls that you liked over time, a lot of lower RGs with medium to higher differentials, but not a tremendous amount of asymmetry. So that made us kind of gravitate more towards the symmetrical. So the idea was to take, in this shape, we're still trying to create that volumetric mass. Now if you look, that's two different ellipses, but it is symmetrical because you cut it one way and you cut it another, you have the same amount of mass. So this is a symmetrical ball, but what's unique about it, it has actually some principles of asymmetry to it.
Okay.
So you take those, and the idea was, okay, how can I take the things that he's liked in the past? So I know he loves symmetricals, but let's take a shape that we had great success with and let's take it and enhance it. So knowing that we can create a certain amount of volume to it, and then we create these ellipses, and then we create this middle band across. And what that middle band does is it gives it stability.
Okay.
So if you have
creates a control.
Creates the control.
Okay.
But the uniqueness of it is that when this ball's in motion, it's rotating. So it's rotating. We set it off on its axis, say at 4 inches from your PAP, which would be about a 45-degree tilt. As it's traveling down the lane, it's rolling. So you have this shape that's turning over itself across the pin, but it's also trying to rotate around itself as well too. So those two ellipses, they turn and it continues to create motion. It's what we call like a helical arc. So think about a corkscrew as it's traveling. As that one ellipsis turns, the next one's
coming around with
and rotating it.
Okay.
So you always have a constant motion. So you said, I want to create something that gives me a read through the middle of the lane and continuous hook, something that is a benchmark. We talked about, you know, some lower, like special agents, and we went way back and other parts that you've used over time, and you've had successes with some Sonics, and you've had successes with Phase 2s and things like that, which were lower RG balls. But we talked more and more about trying to create that all-around ball for a lot of players, and something that's unique. Because what we've seen is, a Storm and Rotogrip both, there's a little bit of a gap in the middle there. And so we give you the idea of a low RG, but with still a tremendous diff, so we still create a little bit of push, but with a lot of read through the middle of the lane.
Well, the one thing that is really cool, looking at it, we don't have anything with these numbers, not in our line, not in Rotogrip's line, nothing. It's very unique. You know, it has an RG, a low RG of 251, which we don't have.
No, we're mostly in the 2.4s.
That's right. Yeah. Or the higher range.
2.5s. Yep.
And the differential on it is what? 0.50. I mean, again, we don't have those two numbers correlating with each other anywhere in our range. So what we saw in the testing facility and why I was gravitating towards it, which is what I was telling you guys down there, was I've never seen this shape. Like I keep wanting to pick it up because it's new and it's cool. It's going through the pins the right way, and I've never seen it before. That's why I kept gravitating towards it. Now it all makes a whole lot more sense, understanding, well, it's because we don't have anything like it in our line.
Right. And we had some other parts down there that were the lower RG parts with the higher differentials that we talked about. We had some smaller shapes that wanted to spin faster. And through the process of elimination, you said, well, I've kind of seen that before. And boy, I really like that one. You really liked the one shape, which was close to some others that we've had. But this one kept standing out, like you said. You kept gravitating towards it because we're still giving you that read that it likes to kind of want to read like a low RG ball, but it still has that tendency to push through the front, read the middle of the lane, and continue off the back. Where we sometimes get trapped is some of our balls want to read too fast front to back, and then they lose energy down lane. And then we have other balls that go a little too far and are too sharp down the lane. There was one that you were really kind of pulled to, was the other one with this shape inside it,
With a different cover.
with a different cover that went farther down the lane and responded to the friction, which still could be very valuable down the road.
Yeah.
We create this first design, we create this benchmark, we create this first signature of this shape, and then we basically branch off of this one. Because I think there's many options down the road for this to even change the densities a little bit. We can raise the numbers or lower the numbers a little bit.
It is so exciting. It's just, I hope you guys love this, because I mean, after throwing it in the test phase, after learning what's inside it, after learning what's on the outside of it, I wouldn't change it. Like, there's nothing, now that I know everything, I wouldn't say, oh, Hank, do you mind if we just change these things?
Sure.
Like, it's such a good ball. I'm really excited to have you guys out there rolling it, throwing it, posting your scores about it, and letting me know how much you love it. It's going to be awesome. Now we've got to think of a name for it. We've got to make it pretty, throw some colors in there. And then we're going to make it have a nice fragrance too. So I guess that's the next step.
Yeah, you can get with the marketing team. The R&D team did what we needed to do. Now the marketing team, you guys can get together and do that.
I'm sure you have some good ideas on how to make it smell nice.
Absolutely. But yeah, we'll let you guys work that out.
All right. Thank you so much, Hank.
Thanks,
I
Jason.
really appreciate it.
Okay.